40 light-years away, in a corner of the cosmos where starlight burns dim and shadows stretch endlessly through cold space, a faint red ember glows. It's a star so small, so quiet, it would be utterly lost in the glare of our sun, and yet, orbiting this humble star is a world that has reshaped our imagination, challenged our understanding of existence, and awakened one of humanity's oldest questions: are we alone? This is the story of TRAPPIST-1e, a planet that, more than any other we've found, stands as a whisper from the universe saying, look again. Earth might not be unique. In the vast black ocean of space floats a star completely unlike our sun. It burns cool. It burns faint. It burns so incredibly slowly that it will likely survive for trillions of years, long after our own galaxy has reshaped itself, long after our sun has swelled into a red giant and turned Earth into a distant memory. This star is TRAPPIST-1, an ultra-cool red dwarf, barely larger than the planet Jupiter. It doesn't blaze with brilliance. It flickers in the dark like a cosmic ember, ancient, fragile, and patient. From Earth, you'd never notice it without a powerful telescope, but to astronomers it represents pure possibility. Because in its quiet, steady orbit lies not one world, but 7 rocky worlds, all similar in size to our own planet, locked in place like jewels in gravity's crown, and among them one stands out. A world that seems almost too perfect, too familiar, too Earth-like to be a mere coincidence. This is TRAPPIST-1e. TRAPPIST-1e is a puzzle, a cosmic reflection of our own home. It's almost the exact same size as Earth. It has nearly the same mass. Its density screams one thing loud and clear: this is a rocky planet, it's not a gas giant or an ice sphere. It's a world with a solid surface, a place where winds could blow, where oceans might ripple under a crimson sky, and where mountains could scrape the clouds of an alien atmosphere. But here's where the story gets even more fascinating. TRAPPIST-1e orbits its star in what astronomers call the habitable zone. It's the Goldilocks region, not too hot, not too cold, but just right for liquid water to potentially exist on its surface. And as we know, where there's liquid water, there's the potential for life as we understand it. This planet receives about the same amount of starlight as Earth does from the sun, making it a prime candidate for a stable, temperate climate. Imagine standing on the surface of TRAPPIST-1e. The sky above you wouldn't be a brilliant blue, but a perpetual, beautiful twilight of reds and oranges, lit by a star that hangs in the sky like a giant, dim, red lantern. Because the planets in this system are so close together, you'd look up and see the other 6 worlds as giant moons, some appearing even larger than our own moon does from Earth. It would be a celestial ballet, a constant reminder that you are part of a bustling cosmic family. But there's a catch. Life on a world like TRAPPIST-1e would face challenges we can barely comprehend. The planet is tidally locked to its star, meaning one side is trapped in eternal daylight, while the other is frozen in perpetual night. A searing hot desert on one half, a desolate ice cap on the other, so where could life possibly thrive? The answer might lie in the Terminator line, the twilight zone that separates day from night. In this sliver of permanent dawn or dusk, temperatures could be mild and stable, creating a narrow band of potential habitability circling the entire globe. Here, under the dim red glow, in a world of endless sunset, life might find a way. The star itself presents another danger. Red dwarfs are known for their violent temper tantrums. They can unleash powerful stellar flares, blasting their planets with deadly radiation that could strip away an atmosphere and sterilize a surface. For TRAPPIST-1e to be habitable, it would need a powerful magnetic field and a thick atmosphere to shield it from its star's fury. Does it have these things? We don't know yet, but the possibility is electrifying. So how do we find out? How do we bridge the 40 light-years of empty space to answer these questions? The answer is light. With instruments like the James Webb Space Telescope, we can study the starlight that passes through TRAPPIST-1e's atmosphere. As the planet transits or passes in front of its star, the elements in its atmosphere will absorb specific wavelengths of light, leaving behind a unique chemical fingerprint. We're looking for the telltale signs of water vapor, oxygen, methane, and carbon dioxide, the very gases that point to biological processes here on Earth. Finding these biosignatures would be one of the most profound discoveries in human history. It wouldn't just mean we found another world with an atmosphere. It would mean we found a world that breathes, a world where something is alive. It would be the moment humanity realizes it is no longer alone in the grand cosmic theater. The discovery of TRAPPIST-1e and its siblings has fundamentally changed the search for extraterrestrial life. For centuries, we looked for mirrors of our own solar system, a yellow sun, a blue planet. But TRAPPIST-1 taught us that the most common stars in the galaxy, the faint red dwarfs, could be the most promising places to look. There are billions of them in the Milky Way alone, and if they all have planets, then the number of potentially habitable worlds is staggering. The universe could be teeming with Earth-like planets, hidden in the dim glow of stars we once ignored. TRAPPIST-1e is more than just a distant point of light. It's a symbol of hope. It's a scientific quest that unites us. It's a story that fuels our oldest and most enduring dream, to look up at the night sky and know that somewhere out there someone might be looking back. We may not have all the answers yet. The journey to understand this distant world is long and filled with challenges. But every new piece of data, every faint signal we capture from 40 light-years away, brings us one step closer to solving the ultimate mystery. The story of TRAPPIST-1e is our story. It's a testament to human curiosity, our relentless drive to explore, and our courage to ask the biggest questions. This pale red dot orbiting a quiet, ancient star reminds us that the universe is far stranger, more wonderful, and more full of possibility than we ever dared to imagine. And the search has only just begun. You look up, and the horizon, though alien, sparks a feeling deep inside you, a sense of belonging on a planet no human has ever seen. This is TRAPPIST-1e. Planets like this are incredibly rare in the cosmos. Most are too small, their atmospheres stripped away into the void. Others grow too massive, crushing themselves under their own immense pressure. But TRAPPIST-1e? It exists in a cosmic sweet spot, a delicate balance where a world can breathe. It's not just another ball of rock floating in space. It's Earth-like in the ways that truly matter. And yet, it orbits a star so radically different from our sun that it challenges everything we thought we knew about life itself. This is the story of a distant world that might just be the most important discovery in our search for a second Earth, a world that forces us to ask, are we truly alone? To understand the miracle of TRAPPIST-1e, we have to talk about the Goldilocks zone. It's a simple but profound concept. For a planet to support life as we know it, it can't be too hot, and it can't be too cold. It has to be just right. On Earth, this means orbiting our sun at a comfortable distance of about 93 million miles. Any closer, and our oceans would boil away. Any farther, and they would freeze solid. TRAPPIST-1e orbits its star incredibly close, far closer than Mercury is to our sun. If it were in our solar system, it would be a scorched, lifeless cinder. But its star isn't a blazing yellow giant like our sun. It's a TRAPPIST-1, a cool, dim red dwarf. This star is much smaller and less powerful, so its habitable zone is huddled in tight, and that's exactly where TRAPPIST-1e is located. It receives just the right amount of energy to potentially sustain liquid water on its surface. Not too much, not too little, just right. This is the same delicate dance of energy that has allowed life to flourish on Earth for billions of years. The warmth from a star, the cold of deep space, and that perfect middle ground where oceans can form, clouds can drift, and rivers can carve their way through continents. TRAPPIST-1e might be living in that same miraculous balance. But a planet is more than just its orbit. It needs a shield. It needs a guardian. It needs an atmosphere. What is a world without air? It's a silent rock, a frozen tomb, a barren wasteland, forgotten by time. Think of our own moon pockmarked with craters exposed to the harsh vacuum of space, a monument to silence. An atmosphere is so much more than just a layer of gas. It's the planet's life support system. It traps heat, keeping the world warm when it turns away from its star. It shields the surface from deadly cosmic radiation. It creates weather, drives seasons, and carries the water that falls as rain. An atmosphere is the very breath of a living world. And here's the most exciting part. TRAPPIST-1e, against all odds, might have held on to its atmosphere. This is a huge deal because red dwarf stars like TRAPPIST-1 are known for their violent tempers, especially in their youth. They can erupt with powerful flares, lashing out with intense radiation that can strip a nearby planet of its atmosphere entirely. For a long time, scientists worried that any planet orbiting this close would be sterilized. But something may have protected this world. Perhaps it has a powerful magnetic field, a planetary shield deflecting the solar storm. Or maybe, as the young star raged, the planet's oceans boiled into a thick, steamy atmosphere that later rained back down, replenishing itself over eons. Or perhaps it was just a matter of luck, of being in the right place at the right time. Whatever the reason, the possibility that it has an atmosphere has turned this distant world into one of the most compelling targets for the James Webb Space Telescope. Right now, as you're watching this, that incredible observatory might be pointed at TRAPPIST-1e, prying into its sky. It's searching for the faint fingerprints of gases, the chemical signatures that could tell us what its air is made of. Scientists are hunting for telltale signs: oxygen, a gas tied so closely to life on Earth; ozone, which forms a protective layer; methane, which can be produced by both geological and biological processes; and of course, water vapor, the key ingredient for oceans, clouds, and rain. Finding these gases wouldn't just mean the planet has air. It would speak of complex chemistry, of geological activity, of a stable environment. It would be the strongest hint yet that the planet is not just habitable, but maybe, just maybe, inhabited. The very nature of this solar system is a spectacle. Imagine standing on TRAPPIST-1e and looking up. The sky wouldn't be blue like ours. Because a red dwarf star emits light primarily in the red and infrared spectrum, the sky would likely be a perpetual twilight, painted in hues of orange and salmon. Its sun, TRAPPIST-1, would appear much larger in the sky than our sun does, a dim, glowing crimson orb. And you wouldn't be alone. TRAPPIST-1 is a system of at least 7 rocky planets, all orbiting closer to their star than Mercury orbits our sun. From the surface of TRAPPIST-1e, you would see its neighboring worlds not as tiny pinpricks of light, but as massive, tangible disks in the sky, some appearing as large as our moon or even larger. You could watch their phases change, see their weather patterns, and witness planetary transits with your naked eye. It would be a celestial ballet unlike anything we've ever seen. These planets are also likely tidally locked. This means the same side of the planet always faces the star, just as the same side of our moon always faces Earth. This creates a world of stark contrasts. One hemisphere would be locked in perpetual daylight, while the other would be in eternal night. Life, if it exists, would likely cling to the Terminator line, the twilight zone between the searing day side and the frozen night side. Here, in this sliver of permanent dawn or dusk, temperatures might be mild enough for liquid water to flow and for life to find a foothold. So what's next in our search? The James Webb Space Telescope is our eyes on the universe. By analyzing the starlight that passes through TRAPPIST-1e's atmosphere during a transit, the telescope can detect which wavelengths of light are absorbed by gases. This technique, called transmission spectroscopy, is our key to unlocking the secrets of its sky. The initial findings have been tantalizing but inconclusive. Early observations ruled out a thick, hydrogen-dominated atmosphere, which is good news, as that would be inhospitable. This suggests that if an atmosphere is there, it's likely a denser one, composed of heavier molecules like carbon dioxide, nitrogen, or oxygen, just like Earth's. Every new piece of data brings us one step closer to an answer. TRAPPIST-1e represents more than just a single target. It's a symbol of a new era in astronomy. For millennia, we have stared at the stars and wondered. Now, for the first time in human history, we have the technology to move beyond wondering. We can analyze the atmospheres of worlds light years away and search for the chemical building blocks of life. TRAPPIST-1e is suspended between hope and mystery. It is a world that feels both deeply alien and strangely familiar. It reminds us that the conditions for life might not be unique to our small blue dot. The universe is filled with countless stars and even more planets. And if a world like TRAPPIST-1e can exist, with its Earth-like size, its rocky composition, and its place in the life-giving warmth of its star, then who's to say there aren't thousands or even millions more? The quest to understand TRAPPIST-1e is the quest to understand our own place in the cosmos. One day, we may see those telltale markers in its atmosphere, a flicker of oxygen, a hint of water, and know that we have found a world with the potential for life. Until then, it remains a beacon of possibility, a testament to the endless wonders waiting to be discovered in the great, dark expanse of space. This is a world that could hold the one thing that makes our own planet so special: water. Where water flows, life follows. On Earth, this is the first rule of biology. We find life in the deepest oceans, in the highest clouds, and even clinging to superheated rocks miles underground. Water is the universal solvent, the cradle of creation. And models suggest that TRAPPIST-1e might have been born rich in this precious liquid. Imagine an ocean stretching across its entire daylit side, shimmering under the gentle crimson glow of its red dwarf star. On the far side, frozen continents of ice, locked in an eternal silent twilight, but the water might not be on the surface. It could be hidden underground, warmed by the planet's own volcanic heart. This internal heat could create a global system, cycling water and nutrients just as Earth's deep ocean vents breathe life into our darkest seas. If TRAPPIST-1e has a rumbling, active core, if gases are constantly replenishing its atmosphere, then it might be more than just a world with water. It could be a world that is truly alive. A living, breathing planet waiting for us to find it. But life needs more than just water. It needs time. Time is the silent architect of evolution, the force that transformed microbes into minds over billions of years on Earth. Our own sun, as brilliant as it is, has a lifespan. One day it will expand, consuming the inner planets, and all that we know will vanish. But TRAPPIST-1 is a different kind of star. It's an M-dwarf, a star that burns its fuel with incredible efficiency. It's eternal by comparison to our sun. TRAPPIST-1 will burn gently for trillions of years. Trillions, that's hundreds of times longer than the current age of the universe. This provides a stable, long-lasting home, far longer than our sun ever could. Planets orbiting such a star have time unimaginable, staggering amounts of time for life to take hold, to evolve, to adapt, and to flourish in ways we can't even begin to comprehend. Now, it's true that red dwarfs like TRAPPIST-1 can be violent in their youth. They erupt with powerful flares, capable of stripping a young planet's atmosphere and bathing its surface in radiation. It's a chaotic, dangerous childhood. But TRAPPIST-1 is an old star. It has aged. Its early tantrums and furious storms have calmed down, settling into a long, quiet peace. Its planets now orbit in a stable, predictable rhythm. Life, if it ever began there, would not be rushed. It would have eons to grow, to diversify, and perhaps to dream. Yet there's a fascinating twist to this world. TRAPPIST-1e is fundamentally different from Earth in one dramatic way. It doesn't spin freely on its axis, it is tidally locked. Just like our moon always shows the same face to Earth, TRAPPIST-1e always shows the same face to its star. This creates a world of stark extremes. One side is locked in permanent, searing daylight, while the other is frozen in a perpetual, icy night, a world of fire and a world of shadow. So where could life exist? Not in the extremes, but in the space between them. Picture a ring, a band of twilight that encircles the entire planet, where the light of the star is forever low on the horizon. This is the Terminator Zone, a region of eternal sunset. It's neither scorched by endless day nor frozen by endless night. Here, in this delicate, temperate ribbon of balance, life could thrive. It would be a world of gentle light and stable warmth. Imagine standing there. You would see a sky washed in a permanent orange or crimson glow. The star wouldn't rise or set. It would hang there, motionless, forever near the horizon. It's a land defined by tranquility, bathed in an eternal golden hour. The life that evolved here would know the rhythm of day and night that has shaped every creature on Earth. It would know only this constant, gentle, forever dawn. What kinds of eyes would evolve to see in such light? What kind of plants would grow? It's a breathtaking thought. And unlike Earth, TRAPPIST-1e is not a lonely traveler in its system. It shares its cosmic neighborhood with 6 other Earth-sized siblings, all packed incredibly close together. They are engaged in a complex gravitational dance, a symphony of orbits so tight that the planets constantly tug on each other. These gentle pulls could stir up tides in any oceans, and perhaps even fuel the volcanic heartbeats deep beneath their crusts, keeping the planets geologically alive. Look up from the surface of TRAPPIST-1e and the sky would be spectacular. You wouldn't just see distant points of light. You would see other worlds not as faint stars but as huge glowing disks, appearing larger in the sky than our own moon. Imagine seeing the phases of another world, watching its continents and clouds drift by. You could witness landscapes hanging in the heavens, entire alien coastlines silhouetted by the reflected light of the central star. 7 worlds, 7 chances for life, 7 potential homes, all clustered together in one ancient, fragile solar system. This raises an electrifying possibility. If life arose on just one of these worlds, could it have traveled to the others? This idea, called panspermia, suggests that microbes could hitch a ride on asteroids blasted from a planet's surface by an impact, surviving the journey through space to seed another world. In the TRAPPIST-1 system, where the planets are cosmic neighbors, this journey wouldn't be a billion-year trek. It would be a short hop. Life might not be isolated on one planet. Biology could be a shared phenomenon, spreading from world to world, creating a true system of life. Evolution in the TRAPPIST-1 system might not be a lonely affair. It might be a cosmic collaboration. So, is TRAPPIST-1e a water world? A twilight planet? A seed of a system-wide biosphere? We don't know yet. But it represents one of our greatest hopes in the search for life beyond Earth. It's a testament to the fact that the universe is more creative, more strange, and more wonderful than we ever imagined. Each new discovery brings us closer to answering that ultimate question: are we alone?